As I told, if if the function is differentiable at a, if the f and g are and with no doubt f of a and g of a is equal to 0, and f and g are differentiable at a, why there is no necessity whenever we are finding the limit of f of x and g of x as x tends to a, you can say direct, how can we find out it's even though this x tends to a, f of a is equal to 0 and g of a is equal to 0 by 0 form, even we can get if the this condition is satisfied, if f and g are differentiable at a, mm, why there is no necessity of L-hopital rule and extra theorems? Very simple logic. Write the limit using derivative. Since we that f dash of a exists, we can rewrite like this. No problem. Limit of f of x minus f of a divided by x minus a as x tends to a, means we are going to find out the change in the output as a minute change in the x, means whenever x is from x is very close to the a, here x tends to a, means whenever x from to a, here x is what, here x is just a main, just a small increment from the a, here whatever here you are putting here, x is maybe a plus h, here h may be a, if it is negative you can get left hand derivative, and if h is greater than 0, here a is x is equal to something a plus h here. Okay, keep in mind. Therefore, I'm the limit of f of x minus f of a divided by x minus a here. Uh, that we can say that whenever x is very close to the, we are putting x is equal to something. Whenever what we are putting here, x is equal to close to the a, means we are going to put the x is equal to something a plus h, like that ratio is given by f dash of a, that is since f of a is equal to 0, that given by limit of f of x divided by x minus a, because f of a is equal to 0. Similarly, g dash of x is equal to limit of g of x minus gx of a as x tends to a, because as I told you, we are going to, why this ratio give f dash of a, because we are putting this value x, what we are going to put, x is very close to the a, means something x is equal to a plus h or a minus where h is greater than 0, maybe less than 0. If you work out that ratio, we are going to find out a plus h minus a means h, finally it gives f dash of a, that's all. Now uh, since find the from the derivative definition, this whatever the is x tends to a, this ratio f of x divided by x minus a tends to f dash of a. Okay, keep in mind, as x tends to a, this ratio f of x divided by g of x, f of x divided by x minus a tends to f dash of a. It means that f of x can be written as g of x minus a into f dash of x into some, I can say that small. Okay, because what we can say, yes, of course, otherwise it is not exactly f of x is something like, we can call this is f of x is equal to x minus a is equal to f dash of a plus some, plus some error is there, no, you can get error, then if you multiply it, you can rewrite f of x divided by x minus a is equal to f dash of a some plus some error, that if you multiply again f of x is equal to, then you can get like this. Okay, definitely, because f of x divided by x minus a is equal to f dash of a sums plus some error, because it is tending to f dash of a, exactly not equal to a, some small error is there, therefore you can write like this. Okay, similarly you can write g of x is equal to x minus a into g dash of a divided plus small error. Okay, now, this is our same thing we defined here. Therefore, can rewrite this f of x divided by g of x is equal to x minus a plus f dash of a uh, plus small r divided by g x minus a. If you cancel x minus a, there as x tends to a, finally this value is equal to what happens? almost the as extends to a small error will going to become zero here. Therefore we can finally we can get it like this: the limit of f of x divided by g of x is equal to f dash of a divided by g dash of a, provided only condition g dash of a is not equal to 0. This is how we can show there is no need of L-hopital rule whenever the function is differentiable at a. Therefore, in the L-hopital rule, as I mentioned in the previous video, I told that there is no the we are taking the condition that f is differentiable near a except a, because if it is differentiable, there is no need of L-hopital rule. Okay, this is how we can directly we can apply here. Mm, like that, whenever x tends to a, we can write like this, and small this error will going to tends to 0. Finally we limit of f of x is equal to f dash of a g dash of a. Since there exist, we can find out these values. Okay, this is how we can say like that.